Alright, here should be our last video on Unit 15, which was, not Unit 15, Unit 5, which is radical functions. And in that we had inverses and graphing radicals. So this last one is on inverse functions. So we have a function, we want to find its inverse. Now remember, inverse functions undo each other. Okay, so the input of this function becomes the output of the inverse function, and the output becomes the input. So x becomes the output, and y becomes the input. Right? So we just switch x and y basically, but I want you to remember that's because x is becoming the output and y is becoming the input. Now we're just going to simplify this because we want a y all by itself. So we're going to add 1 to both sides, and then we're going to divide by 3. And so we get y squared equals x plus 1 over 3. And we're going to take the square root of both sides. So we get that y equals the square root of x plus 1 over 3. And then remember, we can rewrite this in just inverse function notation. So we can say the inverse of f of x is x plus 1 over 3. Now, if we think about this, what this means is I can put any number into the first function. Remember, it's like our pesos and our dollars idea. I can put any number into this first function. So let's put 3. So 3 squared is 9 times 3 is 27, minus 1 is 26. Okay? So my input was 3, my output was 26. Now my output becomes the input, so I get 26 plus 1 is 27, divided by 3 is 9, and I take the square root of 9, and that's 3. And do you see how the input of this one became the output of this one? Or, the output of this one became the input of this one. The output of this one is the input of this one. So it's like this circle, remember? It's like, here you've got f of x. There's an output. Then it goes into f inverse of x. And that comes out with an output. And that goes back into f of x, and it just keeps going around and around and around like that. Okay? So let's try finding the inverse of this one. So input becomes output, output becomes input, so x becomes our output, y becomes our input. So we have x plus 1 equals the square root of y plus 2. So then we square both sides, and we get x plus 1 squared equals y plus 2. And we can subtract 2 from both sides. X plus 1 squared equals, minus 2 equals y. And if I needed it in standard form, we could just multiply that out. So we could say x squared plus 2x plus 1 minus 2 equals y. So that'd be x squared plus 2x minus 1 equals y. Now remember, instead of y, this is actually an inverse function, so we're going to call it that. So we're going to say f inverse of x equals x squared plus 2x minus 1. And again, that's what I'm saying is if I put some number into this first function, if I put it into this first function for x, and then run it all the way through, in the end, I'm going to come back to what I started with. Okay, so here we have another one. We want to change input and output, so x becomes our output, y becomes our input. Okay, and then we solve for y, so I have 2x equals 9y plus 1, so I just multiply both sides by 2. 2x minus 1 equals 9y. Divide both sides by 9, and you get y equals 2x minus 1 over 9, and then we just change that to function notation, so it's f inverse of x equals 2x minus 1 over 9. Okay, you know what, I don't think I have one on this, but I really think that it's important for us to look at one of those ones that has an x and a y on top and bottom. So I'm just going to scroll down here, and we're just going to try one of those. I'll just make it up, and let's hope that it works nicely. So we get f of x equals 3x minus 4 over 7x plus 2. So we have this function. We want to switch our input and our output. So x becomes our output, y becomes our input. 7y plus 2. Okay, and now we go ahead and get y by itself, and the way we do that is we multiply both sides by 7y plus 2. So we end up with 7xy plus 2x equals, and those cancel out and we get 3y minus 4. Okay, do you see how I did that? I multiplied both sides by 7y plus 2, and then I just distributed the x in. Now remember, we want to get everything with a y on one side and everything that doesn't have a y on the other side. So we're going to have 7xy minus 3y equals negative 2x minus 4, because I just subtracted 2x from both sides and subtracted 3y from both sides. Now everything that has a y is on the one side and everything that doesn't have a y is on the other side. And so we notice there's a y in each of these terms, so we can just reverse the distributive property. And we can just take that y right outside. We just undo distributing, because that's kind of how it works. And we get to here. And then we divide both sides by 7x minus 3. And we end up with the f inverse of x equals negative 2x minus 4 over 7x minus 3. So that's just one more example. It's not on your study guide, but it's really important to see those. Okay, now we've got the composition rule for inverses. And remember, this just helps us prove that two functions are in fact inverses. So given that we have these two functions, it says prove the two functions are inverses using the composition rule. So remember, the composition rule means I have to have f of g of x has to equal x, and g of f of x also has to equal x. So we have to test both of these. So let's start with f of g of x. So f is our outside function. G of x is our inside function, so g goes inside of f. And then in this one we would have f inside of g. And so f goes in here, 2x minus 7. Okay, so now let's see. Let's just go ahead and simplify them. So those 2's cancel out and we get x plus 7 minus 7. And plus 7 minus 7 cancel each other out, and you get x. So that part of the composition rule shows that they are in fact inverses. And then this one over here, we get 2x minus 7 plus 7 over 2. Well, minus 7 plus 7 cancel out, the 2's cancel out, and we just end up with x. So, therefore, they are in fact inverses because the composition rule shows that f of g of x is x, and g of f of x is also x. Alright, we're going to check the composition rule on this one as well. So, we're going to look at f of g of x, make sure it's x, and then g of f of x, make sure it equals x. Okay, so f is 3x cubed minus 5, and g is the cube root, x plus 5 over 3. And then, let's see, g over here is that something plus 5 over 3, and that something is 3x cubed minus 5. Okay, so we set them up. That's the first thing we want to do, and now we need to see if they really are inverses, so we just go ahead and start simplifying. And we notice that this is a cube root cubed, so they cancel each other out. So we have 3 times x plus 5 over 3 minus 5. Well, those 3's cancel out, so we just get x plus 5 minus 5, which equals x. So f of g of x comes out to be x, so far we're on a good track. Now we look at the other ones. So first we look inside, and we have, let's see, so we end up with the cube root of 3x cubed minus 5 plus 5 over 3. And minus 5 plus 5 cancels each other out. And so we end up with the cube root of 3x cubed over 3. And those 3's cancel out. And what's the cube root of x cubed? Well, it's x. So awesome. The composition rule shows us that those two are, in fact, inverses. And I believe that's it. That's all. Congratulations. You are ready for your test.